I'd like to introduce Daryl and his brother Daryl. These are two characters that Zara and I came up with for me to tell their stories. She would come up with a premise, and these two brothers would go on an adventure. They are different from each other. The one on the right is always honest, and he's kind of timid. The one on the left is outgoing, troublesome, and he's a liar. How do you tell a difference between the two? The liar has this little scar over here on his face. I was at Home Depot last week and I saw these skulls, and I figured what I'll do is go as Daryl and Daryl as my Halloween costume. So I picked these up and I started modeling and fabricating like a fiend for the last week. And we'll go ahead and show you what it looks like.
What is it that you got there, Craig?
I'm Daryl, and I'm Daryl. Ask me a question.
So Daryl.
Yes?
Are you the liar, Daryl?
I'm not telling nothing.
Okay.
He's the liar. He's the liar. No, he's the liar.
All right, one of you has to confess to being the liar. Who is it? Is it you? Is it you? Can you say yes?
Yes. Oops. Yes.
So, Daryl,
Yes.
where are you going?
We are going trick-or-treating.
Your voice sounds a lot like Craig Hollabaugh. No, that's just imaginary.
Yeah, you're making this up.
Oh, okay.
We gotta go. It's getting dark.
All right. Well, I hope you get some trick-or-treat candy. Don't forget your bag for candy.
Sure.
Okay?
Okay.
It's been real.
All right.
Bye.
Happy Halloween, everyone.
Happy Halloween.
Zara absolutely loved Daryl and Daryl. We went out trick-or-treating for a little while, and old Grandpa came home with a bag of candy for himself. Zara and I have big plans for Daryl and Daryl, little future expansion, some more features, but I'm going to go ahead and show you her first time controlling Daryl and Daryl.
Tell a joke.
Okay. One second. We have to kind of think about this. Okay, we got it. So, we're kind of going to take turns saying it. Ready?
Yes.
So, have you heard of the skeleton that walked into the bar?
No, tell it.
Okay, well, the skeleton walked in the bar and he ordered two things. The two things were a beer and a map. Why do you think why is that? It's more of a riddle than a joke.
Because it went right through him.
I didn't ask you.
Because the beer would go right through him. Is that right? That's wrong?
You cheated. You copied him.
I did copy him.
It didn't take long for the costumes to come out and Daryl to put on their own. It was Halloween after all. We're moving into the build log section of this video. If you're not interested in watching this, thanks for watching. But let's get to it. Here's the box I made, the enclosure out in the garage. I glued it together and this thing fit like a charm. This is the first time I've actually built something that out of wood that actually went together like it's supposed to. Here's some parts I pulled out of my bins. Let's go ahead and take a look at what these are. These first ones up here are micro servos. I think they're SG90s. And then I got a bag of these switches somewhere. These are PCB mount single pole, single throw, push button switches. And I have a Turnigy LiPo battery. It's a 12 volt battery, 3 cells. Here's the obligatory Arduino. And here is a like a thumb joystick for a thumbstick. Inside this little bag here is a MP3 player called a DF player. I got this for about $2.50. Here's a Class D amplifier at about 3 watts. This little guy here is an OLED display. And if I can get it to all run on this, we'll go for that. That's an Arduino. I think it's a micro. These are those RGB LEDs. I think they're WS2818. And then this is a pillow block with an 8mm skate bearing in it. Pair of channel locks. And here is one of the Daryls. This is our test Daryl, where I test fit everything on and before I actually started the construction with the real one. The jaw comes off really nice. Kind of looks like Walking Dead there. And those are pieces of irrigation pipe that I got. Let's talk about this first. This is going to be the pan axis. I was just going to get these pillow locks and mount the neck in here, but it turns out that 8mm is too tight to fit something through and get all the wires in. So I roamed around Home Depot and I found these 2 pieces of irrigation pipe for about $1 a piece. They fit together really well and they have really low friction. And there's not really much play in it after I, get it together because both pieces are very straight. Let's talk about these micro servos. These were really cheap ones. I got them for about $2 a piece. And they are really quite junky. I didn't realize that until I actually got the thing together. These horns don't actually fit on these micro servos. That's why I have the channel locks. I had to actually smash them on to get them to fit. Okay, so I use Onshape for all my 3D CAD modeling. It's a free online tool that runs in the browser and it uses OpenGL. So I'm going to go ahead and log in here. And I have my design done right here. It's called the SG90 Pan, Tilt, and Jaw. Not Yaw, but Jaw. So it loads up a workspace, and this thing works fantastic in a browser. I'm running on Ubuntu 16.4. So I first drew up my box. Here's my box. I'll go ahead and turn off the top so you can see what the inside looks like. It's just a regular pine construction with a routed groove up here on top to fit the top into, and a couple of platforms here to offset the neck from the front of the box. So turn those back on. And the nice part about Onshape is you draw in 3 dimensions, but then you can create a drawing from your 3-dimensional drawing from your CAD model, which is the actual what the dimensions are of all the parts. So with this, I was able to get all dimensions. I'm showing them in millimeters and inches. And I actually was able to construct a nice looking box with near 0 defects in the joinery, only because I was using a millimeter tape measure. Okay, so then I need to start the pan and tilt platform. So I went over to this place called GrabCAD, and GrabCAD has got almost $2.4 million CAD files, and I found a CAD model for this SG90. No, it wasn't that one, but it was one of these in here. And so I didn't draw that, but we'll go ahead and show you what that looks like. Onshape has the ability to import and export SolidWorks files, so this is a direct import. And this is a 3D model. You can, and it's, you know, dimensionally accurate. So here's my pan platform. This is the one that's going to rotate the neck right and left. And it fits into this neck part. We'll show you that in just a minute. And then that servo motor fits right here. You'll see that here in just a minute. The tilt platform, well, there's a couple more things. The wires are going to come up through the center of the neck, and they need to get around the motor, so I cut a slot out and they'll come out the back. The tilt platform was quite an adventure to design because it got a lot of features to it. I probably worked on this for a couple hours. Wouldn't take me that long now, but I continue to learn more things about Onshape. It's really a fantastic tool. Here's the neck. It's that piece of irrigation pipe that I was showing you, and it's been extruded to a length of 215 millimeters. Here's the sleeve that neck fits into. And then I have this collar top, which you'll see in just a minute, but this is what the neck actually rides on the sleeve on the top side. So this is it needed to be a low friction bushing, basically 3D printed material on that irrigation pipe, which is some other kind of plastic. Actually is really low friction. Here's the collar. This is the bottom. This is a little clamp that's got an arm on it that's going to clamp on the bottom, and I have a couple of slots here. I wasn't going to glue it onto the bottom because I couldn't take it apart. I put these slots in, and I used a zip tie to actually tighten it onto the neck. Here's the pan and tilt jaw assembly. So let's get rid of, there's a part in here I got to get rid of, that one right there. Let me turn that off. Actually, let me suppress that part. Okay, so this is the neck here. This is the sleeve, this outer piece. Here's that collar on the bottom. Kind of see it's down there. And here's the top bearing itself. So on the platform, you can kind of see the pan platform, and here's the tilt platform, and here's that stepper motor. Not stepper motor. Here's that servo motor itself. Actually, there's two of them. So this one's the jaw motor, and this one is the tilt motor. This is an assembly, so it does include animation. So you can grab this thing here and twist it around. Let me zoom out here a little bit. So you can twist this around and check out its degrees of freedom, as well as this axis here. And I think the servo arms actually also rotate, if I can grab them. Yeah, you can. It's just a little difficult to grab. There's some collision points in here that I was able to use this Onshape to kind of find the collision point. I put a little notch here so that it makes the tilt platform tip up even higher. So you can kind of see that. If I can get this thing to move for me, here we go. If I can tilt this up here, it has a collision point with the back of that motor. So this enables the tilt platform to go about another 5 degrees to look up. But then I have a wire collision problem, so I stuck a little notch right there. Anyway, that's the pan tilt jaw assembly. Here's the sleeve clamp. This is what's going to affix the sleeves to the back of the enclosure. And we'll talk about that push rod pin in a minute. But here's the fully assembled box with the right hand side. This is the Daryl's head. And we'll go ahead and can we turn this one off? I'm going to suppress the top here in just a minute. So you can see that this mounts on the back, and I was using these 3/4 inch brackets. And the tricky part was down here was after I put all this together, I had no idea what the length of this push rod arm was. So Onshape has a lot of tools to measure things in 3 dimensions. So what you end up doing is I kind of got these for the 0 position when the skull's looking straight forward, and you can come in and click on 2 features, and then open up this dialog box here, and it'll tell you what all the distances are in X, Y, and Z. So I was able to figure out center to center spacing on these holes, and then I came in and drew this push rod pin, and I got the length of this just right. And then I assemble it all together, and this is also an assembly that includes animation as well. So you can come in and examine the motion of this thing by, it's kind of tricky. This screen's pretty small to do this video capture, but you can grab this arm down here and see the whole thing rotate. And this did really reveal a little problem down here. It's possible to get this thing kind of out of whack, where you get the this rotation kind of goes past center, and then now the head's going to actually go backwards, and you don't actually want this. And you can kind of see that the servo motor doesn't really go beyond 180 degrees, but it's possible that the neck could go all the way around. And this turned out to be a problem in the software because the mass, this servo motor goes so fast that I could spin this mass with the head, with the skull on top. And when I wanted to stop, like looking all the way over to the left-hand side, the inertia would pull this thing past here, and then the servo would readjust, and then my head would be turned backwards. So I ended up having to do in software, I had to slow down the motion so that it would actually stop before it hit that point. The vertebrae itself, I was able to come over to Thingiverse, which is a 3D printing kind of website, and people publish their models on here, and I found some vertebrae. I ended up choosing this one here, and these are our STL files, so you can directly put those in your slicer program and print these. But this is what this is the vertebrae that I ended up picking. This hole needed to be a little bit bigger, so I was able to translate that the SLT file, STL file, into a step file, and I brought it in here. So we'll see if this is actually going to load here. This step file has a lot of data points to it, so it takes it quite a bit to load. So here's the vertebrae that's been brought in. You can kind of see, there's thousands of vertices here. And I needed to carve out a hole for the neck itself. And so because this is an object now, I can actually just create a plane, stick a circle on a certain radius, and remove the centerpiece. Then I can export this out as an STL file itself, and then I just printed those. So we'll talk a little bit about some problems that I had. I don't have a video for this, but it doesn't matter. Where's the tilt platform? Now I need the assembly. Here we go. Alright, one thing I did not do, which is my fault, I haven't done a lot of mechanical design. I didn't really do a torque analysis on this particular servo here. So, I'm going to mount this rather light. I just assumed I'm going to mount a rather large, hollow skull up here. Actually, it's going to be going this way. The jaw is over here. And it turns out that this moment arm with center of gravity and all that stuff is a little bit too much for the micro servo to pull up. I discovered this on Halloween at about 12 o'clock in the afternoon, and I got really bummed because it wasn't going to work. I had everything all put together, and I went to start writing the software, and I stripped out the gears in one of them, and I didn't bother fooling with the other one. The other thing that happened was if it was able to hold the skull level, this small micro servo doesn't have any holding torque when the motor is, when just from the gear ratio itself, it has very little holding torque. And so what was happening is this motor was making a tremendous amount of noise because it was falling off the set point and turning back on, and falling off, turning back on, turning off. So it was making a ton of noise. It was drawing a lot of current. Two of these little micro servos were drawing almost 900 milliamps of current, and it was loud and noisy. So this was not going to work. That's my fault. I didn't look at any torque analysis at all. I won't make that mistake again. These were also really inexpensive, cheap actually, as I've talked about before. Okay, well, that wraps it up for the CAD modeling. Let's move on to the actual assembly itself. Well, here's the inside of the box. So what I have here is the LiPo battery, and I've got it connected up. I'm using actually an Arduino Mega. And I run all the wires, and you can kind of see that Daryl and Daryl are mounted. Here are the thumb joysticks, and they basically only control the pan at this point. Kind of see the mechanism down there with the bottom collar zip tied onto the neck. These buttons here control the amount of jaw opening. You have the 50% move and the 100% move. Here's that push rod that I kind of just drilled a hole in the jaw and wired it over. These are the troublesome tilt motors. That's the one I stripped out right there. I ended up putting a brace in to kind of hold the tilt at a certain elevation. And they both got their costumes on, and this Daryl is ready for more action.
Hi, trick-or-treaters.
Are those trick-or-treaters? Yeah.
There you go. Thanks, guys.
Yeah!
Have fun.
Trick-or-treaters! Trick-or-treaters are awesome! Yeah, they sure are. I love trick-or-treaters. I bet you do. You're weird. Yes, I am.
What's your name?
My name's Daryl. No, my name's Daryl. We're both named Daryl.
So I think I spent about 60 hours working on this project. It seems kind of ridiculous for a Halloween costume, but everything I learned is kind of applicable to a lot of other things, particularly all the CAD modeling I did. 3D printing, fabrication was a pain. But it doesn't matter, because what ended up happening was exactly what I wanted. Zara had a really great time. She got to play with Daryl and Daryl. And it's going to be a tool for us to learn how to do additional fabrication, adding features to this as well. We're going to put those RGB lights in there, an MP3 player, and we're going to control it all with that Arduino Mega. And hopefully she maintains interest in this and wants to learn how to program. Young people, when they want to program, they don't kind of get why you want to do it. Blinking an LED isn't really exciting. However, Daryl and Daryl have a very long past with both Zara and I. And this is not only a toy, but it's a tool that if she gets interested in this, we're going to be able to control the motion and do music creation, maybe scripts with sound effects, like theater productions with Daryl and Daryl. There's a lot of different things that could possibly happen with this Halloween costume. Well, thanks for watching. Hope you enjoyed it. I know I enjoyed making it. And I enjoyed Halloween for 2017.